So here we are given A, B and C are in GP, that is in geometric progression, and we need to show that log A with a base of x, log B with a base of x, and log C with a base of x are in AP, and the reciprocal log of x with base A, log of x with base B, and log of x with base C are in HP. So let us begin. So we are given that A, B and C are in GP. That immediately follows that B squared must be equals to A times C. Now what we'll do, we'll take the logarithm on both sides, and when we take the logarithm, we'll suppose that the base of the logarithm is x. Now we can rewrite the logarithm on the left hand side as 2 times log of B with the base of x. Here we have used the fact that if we have log of B raised to the power of A, so that becomes A times log of B, means exactly the same thing. And for the logarithm on the right hand side, we have the form log of A times B, so that can be also broken down to log of A plus log of B. So let's use this. This will give us equals to log of A with the base of x plus log of C with the base of x. And we know that when this particular condition is met, we can say that log of A with respect with base x, log of B with base x, and log of C with base x are in AB. They are in arithmetic progression. So this proves part 1. Now we're going to use the fact that if three numbers, let's say A, B, C, are in AP, then 1 over A, 1 over B, and 1 over C are in HP or harmonic progression. So we'll use this fact. We've already showed that log of A with base of x, log of B with base of x, and log of C with base of x are in AP. That this would follow that 1 over log of A with base x, 1 over log of B with base x, and 1 over log of C with base of x. These are in HP. Now we'll find out this value 1 over log of A with base of x. So we have going to use the property here. If we have log of A with a base of B, this is the same as log of A divided by log of B, provided both of the logarithm has a common base of C. So that means our log of A with a base of x, this can be also expressed as log of A divided by log of x, or simply 1 divided by log of x divided by log of A. Here we've divided both the numerator and the denominator with log A, such that we get 1 over, so log x divided by log A. Again, we can use this definition to get log x with a base of A. So that means log A with a base of x is equivalent to the reciprocal of log x with a base of A. So that means reciprocal of 1 over reciprocal of log A with a base of x, that will be equals to log x with a base of A. That gives 1 over log B will be log x with a base of B, and 1 over log C will be log x with a base of C, and they are going to be in HP. So this proves the second part as well.